Welcome back everybody to Gemology for Schmucks. Today's episode is going to be a quick tutorial on how to use the refractometer. So last week in our episode called The Truth About Bling, I was talking about surface luster and you saw the device, the refractometer. So what I wanted to do is give a quick tutorial on how to use the refractometer so that those of you who are aspiring gemologists can have a head start. And those of you that are not aspiring gemologists can at least know how it works. If you're not interested in technical stuff, now is a good time to click away and go watch one of my other episodes. I hope that you have liked and subscribed already before you click away. Alright, so here's how the refractometer works. Let's get into it. Here I want to tell you about how to use the refractometer for faceted gemstones. You can see here that we have a refractometer. The lens in the front can be removed, and this circular piece on top is the polarizing filter. So you can see that there's a lid that lifts up. This shields the reading of the refractometer from outside light sources, which can throw off the reading. And you can see in the middle there's kind of a rectangle of metal. Inside of that rectangle of metal there is a long rectangle of glass with a smaller whitish area in the middle. That's very important. This is called the hemicylinder. Right here we've got refractometer liquid. If you notice on here it's got the numbers 1.80. That is the highest refractive index reading that this liquid can take. There are higher and lower liquids, but 1.80 is the most common for gemologists. It'll cover the wide variety of minerals that we use. Right here is a full spectrum mag light that we use to generate light inside of the refractometer. Other light sources can be used. I've seen my professors actually use the lamp that's on their cell phone, and it does work, but for the most accurate readings you want to use full spectrum light. So right here in the middle of the refractometer you can see the hemicylinder is now illuminated. That's because light is coming from the back of the instrument and bouncing up through this glass hemicylinder. It's an absolutely essential part of how the refractometer works. So in order to use the refractometer, we put a very, very small drop of refractometer liquid on the metal part of the refractometer here. Make sure that you screw the lid of the refractometer liquid on very tight. This isn't a very nice liquid. It smells awful, but it's very effective at doing what it does. So we take our gemstone in question here, we identify a part of it that has a very good polish. If the stone is not polished, you cannot get good enough optical contact with the refractometer and you won't get a clear reading. Then we're going to wipe off the gemstone that we're going to test. Make sure there's no fingerprints or oils or any other kind of substance on the surface of the stone. It will throw off the reading. Then we're going to put that on top of a tiny drop of refractometer liquid that is on top of the metal part of the refractometer. And we're going to very gently, very carefully scoot that onto the center part of the hemisphere. Once we've got that in the center part of the hemisphere, then we look down the eyepiece. It's important to keep your posture, your head, your neck all in the same location because you're not going to be able to read the refractometer from all directions. At the top it starts with 1.3, that's a very, very low refractive index, and at the bottom it goes all the way to 1.8. And you can see there are a couple of tick marks down below 1.8. What we need to do now is we need to look down the eyepiece and we need to locate the gemstone. And it'll be more of like an outline of the gemstone. You need to move your head up and down in order to see where the stone gets kind of cut in half by that black line. That dividing point between the dark and the light is where we're going to see our reading for the refractive index. Once we locate the dividing line, we keep our head in one location. If you move your head at all once you've seen this stone, sometimes the gemstone will go out of sight and it's going to be impossible to read the refractive index. Keeping our eye on the area where the light is split into dark and light areas on the gemstone, then we can pick up the lens and put it on the refractometer. The lens is going to magnify the reading so it's easier for us to see, and then we're going to put the polarizing filter on top of the lens. We're going to take our first reading of the refractive index. So at the bottom of that dark line, we're going to read what that number is and write it down. Then we're going to take the polarizing filter, which is now on top of the lens, and we're going to rotate it at least 90 degrees, maybe 180 degrees. Frankly, I don't pay attention to it. I just rotate it maybe 2-3 times fully around. And you see whether or not that black line jumps. And it should jump up and down every 90-degree turn of the lens if the stone is birefringent. So that means that light is being split inside of the stone. That proves to us that this stone is birefringent. And that's an important piece of information for identifying what this stone is. If that line does jump, you want to record what the other number is because this will help us get an idea of how large the birefringence is. What is the gap in between these two readings? So once we've written down those two numbers, if there are two numbers, if it doesn't jump at all, you're only going to have the one number, and that's okay. We need to continue checking the stone and make sure that we're not missing something by maybe we're looking at the C-axis, so the light, even in a doubly refractive stone or a birefringent stone, the light won't split in that direction, right? So how do we do that? We rotate the stone. So if the stone is facing up and down, like towards us and away from us, then you're going to rotate it maybe 30 degrees to the right. It doesn't matter which direction, but you need to rotate the stone and do the exact same thing that we just did. We look at the line, see where that is, mark that number. Rotate the polarizing filter and see if it jumps. If it jumps, write down the other number. And you want to continue this process. Rotate the stone, turn the polarizing filter, and write down both numbers until the entire gemstone has rotated 180 degrees. If the stone is birefringent, then somewhere in this space we should have seen the maximum birefringence. In different directions, the birefringence will seem larger or smaller. We want to find that direction that is the largest. So whether or not the stone splits light is one important thing, and then the question next is how much does it split light? That's its full birefringence, and we need to write down that number. So what is the range of refractive indices, and then how large is the birefringence? So the high refractive index, the low refractive index, and then what is the space in between those two refractive indices? We write that down, and that is one of the most important pieces of information for identifying gemstones. Once you have finished testing, you want to be very careful about removing the gemstone from the hemicylinder. So scoot it off carefully, make sure you don't apply any downward pressure on the gemstone so it doesn't scratch the glass. Once you have removed it, make sure that you wipe off the refractometer liquid on the stone and on the hemicylinder. Wipe forward to back, because sometimes the refractometer liquid can crystallize a little bit just in air. And if there are crystals in between the glass and the tissue and you press down too much, it can scratch the glass as well. You have to be very careful about this. So what happens if a stone is a high refractive index, a high luster? We've said that only up to 1.8 can we actually read the refractive index of these stones. So if it's above the refractive index that the refractometer can read, then when we look down the eyepiece, you'll see that this area is entirely flooded with red or a rainbow color. And as we move our head up and down looking for that dark area, that division between light and dark, you won't see it. All you see is all red or all yellow or maybe a rainbow up through the highest areas on the ruler of the refractometer. So this one we cannot read, we just record that it's OTL, over the limit. And that'll help us in distinguishing what this gemstone is, but not as clearly as having a refractive index. This is part of why it's so important to look at your stone before you try and take a refractive index reading, because if it's a high luster stone, there's a strong chance that it's going to be over the limit. Remember that high luster is connected with a high refractive index. That's why it's important to use our eyes as well as using tools like the refractometer. For the spot test, this is typically for cabochons, so anything with a domed face. What we're going to do first is rotate the stone around and inspect the surface, and we're looking for an area that has the best polish. Anything that's rough or worn is not going to get a clear reading on the refractometer. It has to be well polished. Once we've identified an area that has a good polish, then what we're going to do is very similar to the faceted gemstone. We're going to put our torch in the back of the refractometer or whatever light source we're using. We're going to open the refractometer hood and put a small dot of refractometer liquid on the metal part of the refractometer. Very, very small amount. For spot testing, we're going to use as small as possible an amount of refractometer liquid in order to get an accurate reading. This is more difficult than testing faceted stones. So once we have identified the area of the stone that we want to test, we're going to wipe off any sort of fingerprints or anything like that that might be on the stone. Then we're going to dip the part of the stone that is highly polished in the refractometer liquid, and we're going to tap it several times on the metal part of the refractometer. This is going to reduce the amount of refractometer liquid on the gemstone. We need this to be a very small dot, because when you read a curved surface on the refractometer, if that dot is not small, we're not going to get a good reading. So we're looking for a small, small, small dot that is only the size of 2 or 3 of the smallest dash marks on that ruler inside of the refractometer. Anything larger than 2 or 3 dash marks, and we're not going to get an accurate reading what the RI is of this curved stone. Same thing, we put the stone on top of that middle rectangle on the glass hemicylinder, and then we move our head up and down until we can see the dot. Then we're going to write down that middle number. This is what we call spot testing. And this is really the only way we can test the RI of something that's cut in a cabochon. So in this situation with a refractometer, we cannot test birefringence of a cabochon stone. You'll need to use other instruments. So I understand this is highly technical, but if you watch this a few times and you get your hands on an actual physical refractometer and a whole bunch of different types of stones, then you'll be able to practice and get competent at this. It is a perishable skill set. So please keep in mind that this is something that you need to practice often if you're going to be good at it. People that are good at it and that don't do it for a couple of years, actually their skill set will reduce. Because remember, it's how well you're capable of locating that dark line division. And once you've located that dark line, it's also important to be able to distinguish where on that dark line the actual reading is. But once you learn the general tips, of course, that skill set will come back quickly. There are different refractometers on the market. There are some that are incredibly expensive, some that are relatively inexpensive. If you're only going for faceted gemstones, then the cheaper models are okay. There are certain ones that you can plug in and they have the light built into them. Those are actually quite good, only for faceted gemstones. But if you want to be able to test the wide spectrum of gemstones, I absolutely suggest getting, if not the Gempro, which is what I was using. If you're trying to test all sorts of gemstones, definitely get one that the lens can be removed and that has a polarizing filter. Those are both important features. You can use whichever refractometer that you prefer. Big names and expensive models are not always the best ones. You know who I'm talking about. The one that I use is a few $100s less than perhaps the most famous of refractometers, but I prefer it over the most famous. I'll put a link in the description for the Gempro refractometer and you can contact the maker directly. The maker of the Gempro refractometer is actually in the United States, so if you're in the United States, it's a great way to get an excellent piece of machinery and support your nation. And so that's all I've got for today. Thank you for joining me. I hope that this has enriched your knowledge set. And those of you that are aspiring gemologists, good luck. Get out there, get some practice in, and you too will climb the ladder of light. And I'll see you next time.